Hi everyone, we are going to be talking about Kirchhoff's second law, the loop rule. So the loop rule is related to the conservation of energy. So first, let's have a look at a diagram over here. We have a diagram, a power source, 4 resistor, R1, R2, R3, R4, and there's 3 current in that circuit that I'm gonna name I1. So I1 is the current going through R1, I2 is the current going to R2, and I3 is the current going through R3, and it is also the current going through R4 in this case, all right? Since it is the same current, they are in series in this case. So the loop rule states that if we take any loop, we add all the voltage gain and the voltage drop, we should get 0 at all time. So the loop rule states that the sum of the voltage in a loop is equal to 0. Okay, so what is a loop? If we look over here, there's 3 possible loops. There's one loop here that link the power source R1 and R2. There's a second loop here. I name the first loop L1, the second loop L2. The second loop goes to R3, R4, and R2. And there's a third one we could draw also that take the outer path. So it goes to the power source R1, R3, R4, and goes back at the beginning. All right. Now let's just look at what this means for L1. It is the simplest one to analyze. So from the point of view of L1, what the loop rule state is if you have a charge over here, it goes through the power source. The power source will give it a push in energy. It's like a pump. So the charge gains some voltage. It gains a voltage of V. Then it strikes a resistance. The resistance slow it down. It loses some energy. It loses some of that voltage through R1. Then it goes through R2, and again it loses the remaining of its energy before getting back to the power source and repeating its travel around the circuit. All right. So according to Kirchhoff's law, the loop rule, the voltage gain here has to equal the voltage drop at R1 and R2. So for the first loop, we got voltage minus I1 R1. Now note, often it is easier to write it that way. We don't know what the voltage drop here is yet, but we know that according to Ohm's law, the voltage drop is equal to the current going through the resistor. So the current multiplied by the resistor. And again, here we have another voltage drop, I2 multiplied by R2, and all of this has to equal to 0. All right. Now let's look at a not so obvious problem, the second loop. So the same rule apply. We will complete the loop, and the sum of the voltage drop in gain will be 0, but it's not as obvious. We have to look at the direction of the current, and note in this problem, it's easy to guess the direction of the current. There's only one power source, but when you have 2, it's not as obvious. So you may have to guess in which direction the current is going in. We are going to be solving a couple of examples, and you will see that even if you guess wrong, it won't matter, okay? But if we assume that the direction of my current are correct, let's see how the loop rule affect our result. So in this case, we got I3 is going through our R3. So in this case, if we have a charge here, it's moving in that direction and strike the resistance, it will lose some energy. So there's a minus I3 multiplied by R3. Same logic with R4, so minus I3 multiplied by R4. Now there's an important distinction with R2 in this case. Look at the current. It's going in that direction. That means the charge had more energy at the top. And if you want to avoid some confusion, you can write plus minus over here. But now in the loop, we are coming in that direction and going that direction. We are going from a point of lower potential energy to a higher potential energy. And because of that, we need to add a plus over here, okay? And that might be hard to grasp at the beginning. You feel free to relook at that part. How many times you need, we will be solving a lot of examples regarding Kirchhoff's law, all right? So the main point, the loop rule, the sum of the voltage has to equal 0 in all loops. So if you start at a certain point, go around the circuit and come back at a certain point, the voltage drop, the voltage gain minus the voltage drop should equal 0 at all time, all right? So that's it for the introduction. We are going to be solving a lot of examples in this chapter, all right? So let's go solve some example.